Say hello, everybody. Hi. Hi. So today we have an E3D printer to show you. Yeah. Are we going to open that box and see what it looks like? Okay, let's open the box then. Yeah, you want to see it. Okay, let's do it. Ready? This is the sharp knife, remember? Let's show everybody. When we touch it, we can get hurt, right? Ouch, ouch. Yeah, we got to be careful around sharp things. You ready to open? You ready to start pulling stuff out? Oh, it's just more boxes. More boxes inside of boxes and a packaging list. Okay, there's that box. You want to open that one up? Ooh, look at those. We got metal extrusions. Well, I've done the bulk of the unboxing. You can see most of that table is taken up with frame components, and I'm not going to bother to take all of the small components out of their boxes until I've got that frame built up. Look at this machining, you guys. This part right here has to be the centerpiece of the whole machine. Like, that is just a lot of beautiful CNC work. They might have been able to cast this piece and then just sort of face it. That might have been cheaper, but you know, as they say in their videos, those guys at E3D are CNC machining nerds. So of course they wanted to CNC, even if it wasn't the most fiscally, you know, responsible thing to do. Table full of parts, check. Tools, check. Tablet with the E3D online Dozuki wiki instruction manual, check. Bag of bolts, check. Let's get to work. All right, how about a little time-lapse action on this video? So you can see we start the build with just this lower plate and the uprights, which are attached with the bolts, which also happen to be feet. There's 5 of those, and then there's some rather large bolts. Next, we get to this back plate, and this is kind of the key. Lots of things mount to it. So this is where I first started to understand the construction technique, and I ran into a little problem that I want to talk to you guys about. I'm installing the first plexiglass plate here, and I'm running into some difficulties in the assembly process. Not that I don't think I will overcome these eventually, but they just make my job very difficult. So you can see here, this is a properly tensioned, torqued down bolt going into the T-nut. And here you can see a T-nut back behind there. That's in the wrong orientation. It needs to be 90 degrees. So let's go over here to this one, and we can see the T-nut is it moves, see? So as I tighten it down, we want it to be at 90. 45 might be good enough. I might have to go with 45 in this case. And you can see the technique is just to sort of like keep trying, keep giving it a bunch of tries until it gets to the turn that you want it. The risk that you run is what I've done here. So in backing this off to try to get it to turn, I fully backed out the bolt from the T-nut, and now the bolt is not long enough to catch that T-nut. So I have to take the whole thing apart just to get those T-nuts started back on these 2 bolts. I've figured out a solution to this problem here. Basically, take your pliers, grab the end of the threads here, just the very, very tip here, like the last thread, and mangle it a little bit. Like, just give a good squeeze, and the mangled thread will bite into the T-nut harder, which gives you the resistance you need. Let me show you what I'm talking about. See, I'm grabbing just the tip. See, that bolt now has that little imperfection there. That will bite into the T-nut. And now you can see that the T-nut will spin into place, and I can continue to tighten down that bolt. So now that I've got that technique for the bolts going through the plexiglass, I was off to the races. Unfortunately, I sort of messed that up, and I got it turned around. I got the bolts installed on the wrong side of that plexiglass plate. But, you know, once I figured that out, I was on to installing the top plate. And then, you know, I had to read the Dozuki quite a bit to understand exactly what they wanted me to do next. You know, it's sort of a forest for the trees thing on this build. They really give you the minutia of each step without sort of giving you the overall picture, which is, you know, not... I would prefer it was different that way. Anyway, so I like to install the bed here, just like the instructions say, before you install the sides, just because it gives you a little, you know, easier access to the bed. But then you install the sides, like you see me doing, and lots of hunting through those bags of screws for the correct screws. They're not very well organized, but you can find what you need eventually. And finally, we install the very back plate, which creates the interstitial space between the back plate and the back plate for the electronics to be housed within. Let's talk about the frame here. Now, E3D calls this the motion system, and Well, you can see from the time lapse that I had a little bit of difficulty assembling it, and really it should have been the easiest assembly ever. It took me about 2.5 hours to get to this point, and it should have taken about 45 minutes. So let me give anybody out there who's actually going to buy this, I'll give you the quick rundown so you don't have to follow those micromanagement steps where they tell you every little thing. Put thread lock on the threads, put the thread in this hole. I mean, it's like, it's just much too detailed. So here's the big picture, which would make this a very easy installation. Right there, holding the bed, there are 4 M4 screws with washers, so that's easy. The chain here, which is the, meant to hold the wiring, these segments pop off. So I popped the end segment off here, as well as the end segment off there, in order to get those threaded in. It was just easier to thread them in without being attached to the rest of the chain. The top and bottom plates here are attached to the extrusions using M8 hardware. And you can see on the left there, that piece of M8 hardware is actually a foot. And on the right, it's just a regular M8 bolt. So at every sort of instance for the uprights, you have feet, including right there in the middle, and that's for the the Z-axis extrusion. Up here at the top, those M8 bolts are just bolts. There's no feet, obviously. Now the rest of this top plate comes pre-assembled, so you don't have to worry about that. And the bed also comes mostly assembled. So like I said, it's just those 4 screws there. For the sides and the back plexiglass pieces or acrylic pieces, this is the hardware that you're using. And like I talked about a minute ago, just mangle the ends of those threads so that they're more easy to work with. And then the orientation for these side pieces is like this, where you can see the diagonal holes slope down and to the right, where the slotted pieces are kind of up high and in the middle. So just remember that is down and to the right and up high in the middle. And then of course it's the mirror image on the other side. So you can see it slips down and to the left, where the slots here are in the middle. In the back, this is the last piece that's going to go onto your printer, and it's got that hole there to the right as you're looking at the back of the machine. And then also as you're looking at the back of the machine, you can see that little cutout right there, and that goes to the left side of the Z-axis pillar. So that was the mistake that I made. I was building this thing from the back, and so I had that on that side. So pretty self-explanatory other than that. These screws here thread through from the back into the Z-axis pillar. So there at the edges, those screws go from the other side towards us. So that's why you need to sort of get that right as you're preparing the panel. You got to get those screws there, and then the other screws are reversed. So that is a pretty easy assembly. Should not have taken me as long as it did. So hopefully for you guys, it'll be a shorter deal. Let's talk about price. Okay, I'm going to flash on the screen the shopping cart before I actually clicked on purchase for this machine, and you can see that I paid £1,350 for just this frame, the motion system. And that comes out to being almost $1,700. That's almost $2,000 just for the metal and plexiglass that you're looking at here. And that is ludicrous. That's insane. That's crazy talk, okay? Why? Why does this cost so much money, even coming from the West? Now, before I continue, sort of bashing on E3D for the overpriced nature of this, let me give the caveat to say that this is the most well-built 3D printer I've ever seen, period. Look at this bed. It's cantilevered out into space, and yet I can still not flex that thing. Like, I'm moving my table rather than flexing that bed. That's incredibly stiff. Everything about this thing, it's built like a tank, okay? But that's clearly the result of engineers who think they should be the designers, right? Engineering has its place, but it's a teamwork thing in all of the companies that I've ever worked with. You have an industrial designer who works with an engineer, and then they have to answer to the bean counter, the accountant or the marketing department who says, we can't sell a printer for $1,700. So clearly this is a company run by engineers who says, oh, we're gonna make what we want, and they just put it out there and see who will buy it. It's a mistake, right? Especially considering the fact that Johnny Ive, the lead designer at Apple, right? The guy who is basically the industrial design center or zeitgeist person for the modern world, comes there from England. There is a massive industrial design thing, that happens in England. It's centered there in England. How can an English company just forego all industrial design? This is so clearly a kit made by engineers with no beauty to it. It does have an engineering beauty, sure, but there are so many little things, even keeping it as a kit, that could have been done had an industrial designer been brought onto the project. Here's one idea, for instance. They could have laser etched into the plexiglass this side up right panel, right? So that's the right panel, and that would be the upper right corner. And that would help with assembly. They could have laser etched that right here, where we kind of wouldn't show that much. It'd be kind of hidden by the pillar. It's like little things like that. There's so many of them that I would change with this design. So this is what happens when an engineer who probably never worked in the real world, at a company that's forced to make money. This is what happens when he's given a project completely to himself and he gets to do whatever he wants. So yeah, I disagree quite a lot with this frame. But that being said, it's bulletproof. It is. It's as rock solid as it comes. The number one problem that I have with it is that CNC crossbar that I was talking about a few minutes ago. Why? Why on earth spend all that time and all that money? That part alone probably cost me $200. Maybe $400 just for that one part. That's crazy. I don't want that part. That's the crazy part about it. I want the carbon fiber that you were talking about, Sanjay, when you were talking to Tom, right? Why did I have to pay for all that fancy CNC machining that weighs more than the carbon fiber? So this is not the reason to buy an E3D tool changer. The reason to buy an E3D tool changer is the duet board with the firmware and the plate, right? And the plate, the tool changing apparatus itself. So unfortunately, if you don't want to think too hard and design your own frame, they've got you over a barrel. You're going to have to buy this ludicrously overbuilt and overpriced thing, and that's that doesn't make me very happy, in case you can't tell. Speaking of things I'm unhappy about, this is all the Bowden tube that I received, and that's because that's all the Bowden tube that I ordered. I ordered 7 100 millimeter lengths. Now, why on earth would anybody order a 100 millimeter length? I don't know. This isn't my design. I don't know how long each segment is supposed to be. This is the tool changer. It's a known length to E3D. They should just sell it as length of Bowden tube 4, quantity 4, because I have 4 tools. Instead, I got super confused here. I was supposed to order 70 100 millimeter lengths instead of 7 100 millimeter lengths. And so now I'm kind of up the creek without a paddle because I can't get this tool system to run without a Bowden tube, and it's not like I can just run down to the local hardware store and get Bowden tube. So I gotta wait, another week or two just for stupid Bowden tube to come in the mail from England? I mean, maybe I can rush deliver this from some other supplier here in the United States, but that's just incredibly frustrating. Okay, let's talk about things that do make me happy, because there's a lot of it. All right, this is the fancy CNC. Look at that beautiful CNC machining. God, that's gorgeous. Again, maybe overdone, maybe a little bit overdone with the CNC. We got to do a flip operation, machine the back, then flip the front. But man, that's just gorgeous. So this is the main tool plate that will move and capture all of the other tools. This is a portion of it. Now there are 3D printed parts of this geometry that I need to print up before I can get this machine working. So I got to get to work doing that. Here is the rest of that. So this is the other side that it mounts to. This is what it captures. You can see that part right back in there. That big T-looking thing. So that's going to get the balls mounted to it, and it's going to capture right onto that. So pretty cool. I've got 4 of those ones that get captured. Obviously just a single one like this. And then there's also 4 E3D Titan extruders. And also in this box here, there's going to be 4 of the like hot ends. You can see the heatsink right there, the blue heatsink. I'm sorry, that's the silicone sock. There's a heatsink in there somewhere. Where did I see that? There it is, right in there. And then, of course, the creme de la creme, the core of the whole machine, the part that makes the whole thing possible is the electronics by Duet. In case you guys haven't figured it out, I'm a total fanboy for Duet. Like, I cannot get enough of this company. They have to be the best thing in 3D printing. Seriously. This is some electronics that I have not yet had on this channel. This is the DuX5. So this is basically the expansion header that goes on top of the Duet Wi-Fi board there. And you can see there's 3 trinamic stepper motor drivers. Let's see if we can get a good look at those. And then over here we have the actual Duet Wi-Fi. This is the very latest version. And I'll tell you what, guys, this was reasonably inexpensive as part of the kit. They must be doing a volume order for E3D, because this was less expensive as part of the kit than I would have just paid for the board by itself. And you can see there's these 3 fuses, 1, 2, 3. So they're getting better at making this thing even more and more idiot proof. And I'm the idiot that they're proofing it against, because I've now burned up 2 of these boards, short-circuiting them. Rule number 1, kids, is do not work on electronics while the electronics are plugged in. So plug everything in, then put power to it, then unplug the power, unplug all the little wires. So you basically turn it on and off a whole lot, but that saves you from, needing to buy a new $175 control board every time you make a stupid little mistake. Finally, we've got the bed, and this is pretty impressive. I mean, I wish it was square, but they needed that extra space for the tool changing stuff to happen. But the coolest thing about this, that just seems so obvious, like I had thought of this years ago, and I don't know why I have not seen it until now, and that is these little clips here to hold the bed on. You see that just that little finger, just a tiny little bit, holding the glass bed onto the heater portion. And that heater portion is a silicone bed heater, which runs on AC mains voltage, so that will get hot nice and quickly. So yeah, all in all, of course, this is going to be a real high quality kit when it's all assembled. I just have to wait until I can receive more Bowden Tube in the mail. So we're going to leave it there. We're going to call this part 1, and when the Bowden Tube comes in, I will fully assemble this printer and we'll get to part 2, the actual tool changers. All right, that's it for now. Thanks for watching. See you next time.